All right, so this lesson is going to be on graphing square root and cube root functions. And I'm going to be going a lot of back and forth between the calculator and the note sheet. So make sure you have your calculator out. And if the video needs to be paused, we can make sure that we do that so everyone stays up to date and I don't go too fast. All right, so the square root parent function is the function y equals the square root of x, right? And I just want to plug in some numbers. If we tried to find, plug in -4, if we type in the square root of -4 in the calculator, that is imaginary. Same thing for the square root of -1. That's not going to work either. But we can find the square root of 0. That's just 0. Right? We can find the square root of 1. That's just 1. All right. Let's skip to the square root of 4. The square root of 4 is just 2. And then the square root of 9, the square root of 9 is 3. All right, so all I did, just in my head, I did a table of values. And I put in 0, 1, 4, and 9, because those were perfect squares. And then so I got the ordered pair 0, 0, 1, 1, 4, 2, and 9, 3. So those were the points I graphed. So you guys go ahead and graph those points if you haven't already. All right, so the square root graph looks like something like that one. Let me try it again. Right. So it doesn't go past, this one doesn't go past that point 0, 0. So that is the end point. Okay. And then if we're looking at the domain, right, this line has a domain from where x is 0 to infinity. So the smallest x where something is graphed at 0, and then it goes forever to the right, which is to infinity. Right. And then for the range, the lowest y value where it's graphed is also 0. And then it's from where y is 0 up forever. So up forever is to infinity. All right, so that's the parent function for the square root function. All right, we're also going to do a parent function for the cube root function. And so the parent function for cube root is y equals the cube root of x. Okay. So I'm going to pick a negative number this time. So -8 is right here. The cube root of -8 is just -2. So you have a point at -8, -2. Right? We could also put in -1 into the cube root function. The cube root of -1 is -1. So I have a point at -1, -1. The cube root of 0 is 0. Right? The cube root of 1 is 1. And then the cube root of +8 is +2. All right, so I did the same thing as I did on the last one. I just put in values that I knew I could do the cube root of in my head real quick. All right, and those were the ordered pairs I got. So I just graphed those. So you guys graph those ordered pairs if you haven't already. So the cube root graph doesn't have an end point. It has what's called a turning point. So I like to say it kind of looks like a snake. So that is what a cube root graph looks like, and it goes on forever in both directions. So the cube root turning point of the parent function is at 0, 0. So that's kind of the middle of the curvy part. And because I have arrow going to the left and an arrow going to the right, the domain is all real numbers, or from negative infinity to infinity. And then because I have an arrow pointing down and I have an arrow pointing up, my range is also negative infinity to infinity. So every cube root function is going to have that range in that domain. Now for the square root, it changes from problem to problem, but that's always going to be the domain and range of a cube root function. All right, so let's review the transformations real quick. And we talked about this during the first quarter. It's been a little while, but we have this transform function where I have this number here, that'll be a number, this could be a number, and that could be a number. So this number here that's subtracted from x is going to give the horizontal shift. And if that is a plus, then it's going to shift to the left. And if that is a minus, it's going to shift to the right. Okay. K is going to give you the vertical shift. So this number added out there is going to be a vertical shift. If it's positive, it's going to shift up. And if it's negative, it's going to shift down. All right. Your turning point or your end point is going to be HK. So also on that one, for the H, you're going to change the sign. So if it's a plus number here, that would be a negative. If it's minus, it would be a positive. All right. If A is negative, the number that is in the front, then the function is reflected over the x-axis. Right? And then A also tells you if the graph has a stretch or a compression. So if A, without the absolute value or looking at it without looking at the sign, is greater than 1, it is a vertical stretch. And then if A is between 0 and 1, then it's a vertical compression. Okay. So I am going to do some of these, and then your assignment today is to do the ones we don't do in class. All right, so I'm going to do number 1. So we're going to describe the transformation. So this one has something subtracted on the inside, like H was here. So that's going to be a horizontal shift. And since it's subtracted, it's going to shift to the right. So this one is going to shift 7 units to the right. All right. This one also has something added at the end. And so that is going to be K. K is a vertical shift. And then since it's added, it's going to shift up. Okay. Let's look at number 4. Number 4 has a lot of things. So number 4, we have this 1/2. So a number in the front, if it's negative in the front, it's going to be a reflection. But if it's just a regular number, then it's going to be a stretch or a compression, vertical. So 1/2 is between 0 and 1, so that's going to be a vertical compression. All right, this one also has 2 subtracted on the inside. And so when something is subtracted on the inside, you're going to shift it to the right. Right, and then we have something subtracted outside, and subtracting on the outside is going to shift it down. All right, we're going to skip and do number 6, but we're going to change it because I don't like the way it's worded. So we're going to mark out has a turning point located at -2, 3, and we're going to do a completely different problem. Okay, so we have the cube root function. And let's say is vertically stretched by a factor of, let's do 4. Vertically stretched by a factor of 4. And shifted 2 units down. So the cube root function is vertically stretched by a factor of 4 and shifted 2 units down. We're going to write that equation. Okay, so I know I have to do a cube root of something. All right. Now a vertical stretch by a factor of 4 means we're going to multiply that by 4. And then think about, to shift down, do you have to do something on the inside or do something on the outside? So to shift down is outside, so it would just be the cube root of x, and then to go down 2, we subtract 2 on the outside. Okay, now we haven't started graphing yet, so we have quite a bit left to do. So let's look at number 7. You guys better be awake. All right, so on number 7, we are going to let our calculator do most of the work. So what we'll do is go to the calculator. Anytime we're going to do a graph, we're going to go to y equals, and we're going to type it in. So we're doing number 7. Number 7 is the square root of x, and then make sure you hit the right arrow so you come out of the square root, and then plus 5. So double check that your plus 5 is not underneath your square root. Right? And then what we're going to do is go to the table of values. So to get to the table, you hit second graph. Actually, before we do that, I want to do something. Let's figure out this turning slash endpoint. Okay, so according to our rules up here, the endpoint or the turning point is the point HK. So the X part is going to come from what's subtracted on the inside, and then the Y part is going to come from what's on the outside. So on this one, nothing is subtracted on the inside. So the X part of the turning point is going to be 0, and then the 5 is added on the outside. So the Y part is going to be 5. All right. So if you notice, if we go up, there's error, because we can't put these numbers in for the square root because we will get imaginary. So we're going to do the table of values of these numbers that we don't get these awful decimals. Now you can graph the decimals if you want to, but I'm just going to use these numbers here that are integers. So 0, 5, 1, 6, and 4, 7. And then we're going to connect them. All right, so that's going to make our domain go from 0 to infinity, and our range go from 5 to infinity. So 0 is the smallest x value where you have something graphed, and then 5 is the lowest y value where you have something graphed. And those should kind of correlate with what we said our endpoint was. Okay, so the end behavior on this is kind of weird. So for your end behavior, we have an arrow pointing to the right. So going to the right is going towards infinity. So as we go to the right, that graph is also is going up, up, up. So that is going towards infinity also for the y. So the x, as x approaches infinity, is the right side of the graph. F of x approaches infinity means is pointing upward. Now, the left side of the graph doesn't have an arrow. So the left side of the graph, x is approaching 0. So that's going to match that part of the endpoint. And then the y is approaching the y part of the endpoint. So that would be 5. Right? And then increasing and decreasing we've talked about before. So for the increasing interval, is everywhere on the graph. So this one, like if you're walking on it from left to right, you're going uphill always. And so that interval isn't going to start until 0 because that's where the graph starts, but it's going to increase forever to the right. So that would be infinity. And this one doesn't have a decreasing interval. Okay. So I'm going to skip to the back, the last page. Okay. We're going to do number 10. So before we put it in the calculator, let's go ahead and find our endpoint/turning point. And so remember, we look at, for the x part, we look inside the bracket or the radical. Since it's a -2, it's going to be +2. And then the y part is outside. That's going to be a 3. All right, so let's type it in the calculator. So go to y equals and clear that out. All right, then we're going to type it in. So to get cube root, you need to hit this math button right there. And then cube root is number 4. Nope, I messed it up. Sorry. Let me start over. Let's do this negative first. And it's not a cube root, it's a square root. So square root is second x squared. And then we have x minus 2. And make sure you come out of the radical and then do the +3. All right, so what we want from this is the table. All right, so same thing like before, we have errors up there. Anything that is on the left side of that endpoint. So I'm just going to use those 3 points there that are not these ugly decimals. So the point 2, 3, 3, 2, and 6, 1. So those are the points I'm going to graph. And then this one, so make sure if we said there's an endpoint at 2, 3, that actually stops right there. And you can always take a little peek at the actual graph if you want to make sure you're right. And to do that, you just hit the graph button. Okay, then for our domain, the smallest x value in our domain is 2, and it goes forever to the right, so this 2 to infinity. Right, the range is a little different on this one because I have an arrow pointing down, so the smallest number in our range is actually negative infinity, and the largest number in our range is going to be 3. So remember that the domain should match up with the endpoint, and the range should match up with the y part of the endpoint. Okay. So if we look at the right side of this graph, we have an arrow. So as x is going to approach infinity, the y, because this arrow is kind of pointing down, the y, or f of x, is going to approach negative infinity. Okay, the left side of the graph, we have our endpoint. So make sure when we do this one, we use those endpoint values. So as x approaches 2, the f of x, or the y, approaches 3. So as we go to the left side, it stops right there. Okay, and then if we were going to walk along this graph, we would always be going downhill. So there is no increasing interval. There is only decreasing intervals from 2 to infinity. So remember on that interval that we used x. I didn't say that on the last time, but those are x values we're talking about for increasing and decreasing. All right, so let's do a couple of these cube root graphs. Okay, so let's do our turning point. So we're going to look inside the radical. Since it's a plus 3, the x part of the turning point is going to be negative 3. And then the y part is going to be 2. So we don't change the sign on the y. You only change sign on the x. All right, so I'm going to get a table of values from my calculator. Okay, here we go. This is what I tried to show you last time. It was too early. So to get the cube root, we're going to hit math. And then cube root is number 4. And then I'm going to go to the table. All right, so I see some decimals. I know I want my turning point in there. And my turning point was all the way at negative 3. All right, so I went a little too far. Negative 11 is not going to fit on my graph. But I can get that. Negative 4, 1, negative 3, 2, negative 2, 3. And I think I can get one more point. Yes, 5, 4. So you're just kind of scrolling through those points. These graphs go from negative 10 to 10 and just seeing what all you can graph. That's not an ugly decimal. All right. So this is the one that kind of looks like a snake. And if you want to just kind of double check yourself, you can hit graph and see what the graph looks like. So it continues going in both directions. Right, so on these cube root graphs, your domain and range are both going to be all real numbers, or negative infinity to infinity. Okay, and these both have arrows on both sides. So the right side is as x approaches infinity, so it's this side. The y arrow is pointing slightly upwards, so it's also approaching infinity. And then on the left side, as x approaches negative infinity, this arrow is pointing slightly downwards, so f of x is also approaching negative infinity. All right, and then if we started walking along this graph, we are walking uphill everywhere, which means the increasing interval is from negative infinity to infinity, and there is no decreasing interval. All right, let's look at number 12. Let's go ahead and get our turning point. I really should have been marking that all along. So this one has a turning point because it's a cube root. The cube root has a turning point. The square root, they all had end points. So if you want to go back, number 7, circle end point because it's square root. Number 10, circle end point because it's square root. Number 11 is a turning point. And number 12 is a turning point because they're cube roots. All right, so this one, nothing is added or subtracted inside, so that's 0. Nothing is added or subtracted outside, so that's also 0 for our turning point. Okay, so we have a negative 2 in front, and then to get cube root, remember you do math, and then number 4. Don't know why I keep double hitting those. Okay, and then we'll go to the table. Okay, so negative 8, 4 should fit on our graph. And then those 3 points right there, negative 1, 2, 0, 0, 1, negative 2, and then 8, negative 4. See if I can remember all those. Okay, so just plot those 5 points. And then, kind of connect them like a snake. And then if you just want to double check your graph, hit graph. You can kind of see what it looks like. It's a little better than what I drew, I think. Not too bad. So on these cube root functions, your domain is negative infinity to infinity, and your range is also negative infinity to infinity. When we go to do our end behavior, we're going to look at what's happening on the right. There's an arrow on the right, so we would say as x approaches infinity, and then this graph is going slightly down, so f of x would be approaching negative infinity. Right? And then on the left, there's an arrow on the left, so x approaches negative infinity. And then on the left, this arrow is pointing slightly upward, so that would be positive infinity. And if we took a walk along this graph from left to right, we would be going downhill always. So the graph is always decreasing, so there are no increasing intervals, but decreasing from negative infinity to infinity. All right, so that's the end of the lesson. Your assignment is going to be to finish the ones we didn't do in class today.